second derivative tells us is concavity. What is concavity? Besides the things that you get in your teeth.
It curves.
And not just if it curves, but like which direction it curves. So if we are concave up, it means that our graph is opening upwards. So it looks like a traditional like quadrant, right? We have like a bowl shape. If it is concave down, it's like a mountain, right? It's opening downwards. Okay, that means concave down. Sometimes you'll also see concave down also described as like convex. That's kind of an older term. You don't really see it much anymore. But basically, like these are very, very simple examples. So like this is concave up everywhere. This is concave down everywhere. But that's not always the case. There are some times where our graph, right, is going to be concave up for part of it and concave down for part of it. And so the points at which we switch from either concave up or concave down are called our points of inflection. And so this is where f of x is defined. F double prime of x equals 0 and f of x changes concavity. Now, the reason that I say that f of x is defined, okay, because this is a nice pretty example of where we would change concavity and have a nice pretty polynomial. However, I can also change concavity when we are undefined. So like if I have a rational for concave down over there and concave up over there. So I have technically changed concavity here. However, it would not be considered a point of inflection because it is not defined for my original function. Yes, no, maybe? Now, as we said, this ties back to our second derivative, which is the derivative of our first derivative. So our graph will be concave up when f double prime of x is positive. It will be concave down when f double prime of x is negative. So it's going to work very, very similarly to how our increasing and decreasing did. We're going to take the first derivative, and we're going to take our second derivative. We're going to set that equal to 0, and we're going to make our little chart to figure out where we're concave up and concave down. So, but when we set it equal to 0, we still have to check for where f of x is undefined. So we have to consider those. Which also means that f double prime of x will be undefined there. So we're just going to include those values because it can change concavity, but it won't be considered a point of inflection. What questions do we have so far? So it says, determine the points of inflection and discuss the concavity for the graph of f of x equals x to the fourth minus 4x cubed. So what do we want to do first? Cool. What's our derivative?
4x cubed minus that's 4x squared.
A? Stop there?
No.
No, because now we're talking about concavity, so we need the second derivative. So what's our second derivative?
12x squared
can create our interval around those points. So what are we going to do? Solve.
Factor out 12x.
Okay, and we're left with.
12x times x minus 2.
And so we get x equals.
0 and 2.
Okay. Alright, all the way with that. Okay, and then we're making a chart. Now, this is our second derivative test, so where do you think we might be plugging our values back into? The second derivative, right? For our candidates test, we plug back into the original function. For our first derivative test, we plug into our first derivative. For our second derivative test, we plug back into our second derivative. Okay? Because again, our concavity is determined by the sign of our second derivative. So it doesn't help us to plug into other stuff because we want the concavity. So what is something that is before 0?
Negative
In between 0 and 2.
1.
After 2.
3.
Sounds good. So if I plug into my factored form, right, 12 times a negative 1 is going to be what?
Negative 12.
Yeah, it's going to be negative. Okay, and then negative 1 minus a 2 is going to be
Negative 3.
also negative. So a negative times a negative gives us a
Positive.
positive. Okay. So now when I plug in 1, 12 times a 1 is going to be a positive this time. But our 1 minus 2 will still be what?
Negative.
Negative. So overall we would have a
Negative.
negative. And then lastly, if we plug in 3, our first factor is going to be positive. Our second factor will also be positive. So overall we are positive. Questions on how we plug stuff in, where we plug stuff in, or where we got those values from? Okay. So then our first thing is, what are our points of inflection? We'll just list the x5s.
0 and 2.
Because that is where we equaled 0, right? But we also had to show that we changed concavity around those 2 points. Because say like, if this was positive and then positive again, we didn't actually change concavity, so it's not considered a point of inflection. Then it wants us to discuss concavity. So where are we? Concave up.
2.
So it's going to be an interval.
Negative infinity to 0.
Mm-hmm. Anywhere else?
2 to infinity.
So then where are we concave down? Or where is it negative?
0 and 2.
Yeah, between 0 and 2. Mm-hmm.
So it has to be an open interval.
Yeah, I mean, it doesn't have to. So you wouldn't be counted wrong for putting a closed interval, but when we're talking about inflection points, you can change concavity at a particular point, but we don't generally say that you're going to be concave up or concave down at that exact point because you're changing concavity. So that's why we leave them open. Same thing like with our increasing and decreasing, right? We leave those open because you're technically changing from increasing to decreasing or vice versa. So you're not doing either one at that point. Yes, no, maybe so. Okay. Alright, next we're determining the concavity for f of x. It's our favorite kind. Yay! Trig functions! Okay, also, this is a very valid non-calculator active question. Okay, so we're gonna practice some of our trig skills that some of us still haven't quite remembered. So the process is gonna be the same. What is our first derivative of tangent?
Squares.
Cool. of the inside. So it's the derivative of secant. So we remember. Okay. Nope. It is secant tangent. If you wanted to go through all of the steps, you could say, right, secant is also 1 over cosine. So you could list this as cosine of x to the negative first, and use the chain rule on that. And then you get this. Yes? No, maybe? Are we okay with that? Or you just remember that it's secant tangent. Anyway. So just cleaning it up a little bit. This is 2 secant squared tangent of x. And then what are we doing with that? Setting it equal to 0. And most of the time y'all are good up until right here. The calculus stuff y'all are fine with. I mean, as long as you can remember your derivative of secant, sometimes that can trip you up. But like the solving of the trig equations when we don't have a calculator is where some of us have some troubles. Now, remember that for this, I have 2 different trig functions. So we do need to think about where both of those trig functions are going to equal 0. Are we okay with that? Yes, no, maybe? Yes. Okay. Now, secant squared is what? Or just secant in general is what? 1 over cosine, yeah? Or so this would be, this is 2, right? So it's 2 over cosine squared. Yes? Okay. 2 divided by what is going to be 0?
Nothing.
Yeah, so like there's not anything that I could plug in here to make that work. Okay. Well, it's not undefined. There's just no solution. Like there's nothing that makes that work. We will have to check where we are undefined in just a second. Now, where does tangent equal 0? There is a solution for that.
0.
It is 0. So remember, tangent is sine over cosine. So it's going to be 0 when sine is 0. And sine is 0 at 0. Okay? Now, the other thing that we did say that we need to check for, okay, are where we are undefined. Okay, where is tangent undefined? Tangent has
Pi
aspects.
and negative pi.
Not quite. Huh? And?
Negative pi.
Yeah, which is why those are our inputs, because that's where it's undefined. Okay? The other thing that we have to think about is where is secant undefined?
Pi.
Negative pi over 2.
Yes. And?
Pi over 2.
Yeah. Because secant is, again, 1 over cosine. So when cosine is 0, it's going to be undefined. Well, this is on the bottom. Cosine is also on the bottom for tangent. So they're undefined in the same spot. So that's why it only gives us this portion, because it doesn't want us to go past the undefined parts. Yes, no, maybe. Are we okay with that? Alright. So, our endpoints are negative pi over 2 to pi over 2. So that's the only part we have to worry about. And then our possible point of inflection is 0. Because remember, I still have to check if I change signs there. Because if we don't, then it's not actually a point of inflection. Now, here's the fun part. Remember, these are trig functions, so we're going to plug in angles, right? But we really only have to think about what quadrant am I in between negative pi over 2 to 0? It's only one.
The first?
It's not, I mean, it's only one quadrant. He listed
Oh.
2 quadrants.
The 4th one.
The 4th, yeah. This is my 4th quadrant. Right? Because it's a negative, so I would be going clockwise. And negative pi over 2 is equivalent to 3 pi over 2. So it's just that 4th quadrant. Now, where are we between 0 and pi over 2?
That's one.
That's the first quadrant. Okay? Now, this one's actually a lot easier because we just have to use our little noggins. Okay? If I take secant and I plug something in and then I square it, what am I always going to get? Everything is positive in our first. And so those would be our signs. Which means, where are we concave up?
0. 0 to pi over 2.
Okay, where are we concave down?
Negative pi over 2 to 0.
Which makes sense because do we remember what our graph of tangent looks like?
Weird squiggly line.
I go fast.
Yeah.
Slow.
Looks like that, right? And we have asymptotes at negative pi over 2 and pi over 2. So notice that before 0, it is concave down, right? It's facing downward. And then after 0, it's facing up. Which this is also an interesting one because this is a point of inflection, right? But it is not a relative min or max. Now f prime would equal 0 here because it does level off, but it's kind of like our cubic graph, right? It keeps going increasing. So it's just a point of inflection there. What questions do we have there? So trig functions aren't all that bad as long as we can remember, you know, a few of our unit circle E things. Alright. Now let's actually look at our second derivative test. So our second derivative tells us concavity, but we can also use our second derivative test to tell us about our relative mins and maxes, just like we did with our first derivative test. And this is helpful sometimes when like I only have information about my second derivative. That can be helpful. I will say like a lot of the time, if you're just given a function, you're going to use the first derivative test more often. But there will be sometimes where you're only given information about the second derivative. So we do have to at least understand the second derivative test. So we're going to start with, so let, I don't want to be blue. Let f of x be a twice differentiable function. What's that mean?
You can take the derivative twice.
Cool. What's it also mean about my function?
Continue.
It has to be continuous. Okay. And we're going to let f prime of a equal 0. What does that mean? A is a critical point. Alright, okay. So I still do need a little information about my first derivative because I need to know where my critical points are. And my critical points can potentially be what? Our mins and maxes. Specifically our relative mins and maxes, or our absolute. We care a little bit more about the relative in this case. So let's think about this. So then, if I am looking at f double prime of a, if that is positive, what does that tell us about our graph? It's concave up. So if we are concave up, and we know that our derivative at a is 0, right? That means that it has to have a horizontal tangent, okay? What type of min or max do I have there?
Absolute.
For that specific example, I could have any, but like, is that a minimum or is that a max? It's a minimum. So then we can say, then x equals a is a relative minimum. Versus, if f double prime of a is negative, now our graph is going to be what? Concave down. So a would have to be a
Max.
maximum this time instead. your positives and negatives work like you think they would, okay? If it's positive, we're concave up. If it's negative, it's concave down. However, because of what your graph then has to look like, if f double prime is positive, I have to have a relative minimum. If it's negative, I have to have a relative maximum. So that kind of does the opposite of like what you want it to do in your head. So it's all, if you always need to, go back to like your basic quadratic. Concave up, oh, that has to be minimum. Concave down, oh, that has to be a maximum. What questions do we have there? Easy. So this says consider the graph of f prime of x. Find the intervals where f of x is concave up or down, and find any x values where f of x is a point of inflection. What is this the graph of? F prime. Okay, so we need to be careful that we are reading our label. But do they ask us about increasing and decreasing? No. They ask us about what? Concavity, which is a second derivative thing. Okay. Can I find the second derivative from that? Or can I gather second derivative information from this first derivative? I can gather second derivative because the second derivative is just the derivative of the first derivative, right? Yes, no, maybe? Are we all okay with that? Okay. And a derivative is the what? The rate of change or the slope of the tangent line. So notice on this graph, on the left side of my graph, what type of tangent lines do we have here? Positive. Okay. On the right side of my graph, what type of tangent lines do we have there? Negative. But because I'm starting with my first derivative, that means that these tangent lines represent my second derivative. And where do those change? That one. So we would say that f double prime of x is going to be, we'll start positive. Where? Okay. Which, if f double prime of x is positive, what does that tell us about our original function? Yep, it's concave up. Okay. And f double prime of x will be negative where? Which means that f of x that also tells us if I switch concavity at x equals 1, then what is x equals 1? Yep. So this is kind of a introduction to what we're going to be doing on Wednesday with our calc house, which is just basically looking at all of the different relationships between f double prime, f prime, and f of x, and how we know when all the things are increasing, decreasing, concave up, concave down. What questions do we have there? Alright, so this one is says determine where the function has relative extremity using the second derivative test. So we'll finish up with this one. So what do we first need in order to be able to use our second derivative test? We do need the second derivative, but like what was the first thing that I wrote though on my second derivative? That f prime of a equals 0, right? So we have to have our critical points. But yes, going back to what you're saying, yes, f of x has to be twice differentiable. F of x is a polynomial. It's twice differentiable. However, I do need my critical points first. So I need to take my derivative first. What is our derivative? Okay, and I need to know where that. Cool. So how do we find that? What do we do with that to solve? We factor it, right? It's quadratic. Yes. No.
Yeah.
Maybe. Okay. So what multiplies together to give us 3 times 7 gives us huh? 21. So what multiplies together gives us 21. That adds together to give us a negative 10x. So what do we get for our two factors? Not quite.
X minus 7, x minus 1.
Okay, so I get x equals.
Minus 7 over 8.
Okay. Then, as we said earlier, yes, we do now need our second derivative in order to use our second derivative test. So what is our second derivative? Now, this is the part where some people get in trouble. Because we have these numbers now. And now some people try and make like a chart with these numbers and do other funky things. And remember, I already know that these are critical points. So now the only thing I have to do is decide if each one of these is going to be positive or negative. So if I plug 1 into there, actually don't care what it equals, am I going to get a positive or a negative? Six minus 10 is negative. Are we all okay with that? I'm just plugging my 1 into there, and it's negative. Okay? And we said that if it's negative, that means we are concave down. So that means that x equals 1 is a relative maximum. If we plug in 7/3, what do we get? Right? Because like 3 goes into 6 2 times. So 7 times 2 gives us 14. 14 minus 10 gives us positive 4.
Yeah.
Which means that 7/3 is a relative minimum. So remember, it means I'm concave up, but like the up, the U shape has a minimum versus the mountain shape has a maximum. Do we all see where we first got our critical points? And then how we decided which one of them was which? Alright, we will stop there for today.